Right, so this paper is focusing on the number questions that crop up on the first 2/3 of an intermediate paper. So it's your D and C grade questions. But there were a couple of bonus questions that we identified, which were to do with standard form and products of prime factors. Those are grade B topics, but maybe ones that you can get your head around. So those bonus questions are question 10 and 11. Pretty much in preparation for the summer exam, questions 1 to 9 now are ones that you need to be able to deal with confidently. So let's take a look at the questions. Question 1. Showing all your working, write 0.65, 3/5 and 7/100 in descending order. So you need to know what descending means. It means going from largest down to the smallest value. And in order to do this, we need to have all three of those fraction, decimal and percentage. Actually, there's no percentage there. It's fractions and decimals in the same comparable form. So either both in fractions or all in decimals. Personally, I would go all into decimals from here, but you know that's down to your choice. So that one, 0.65, stays as it is. Three-fifths, you should know what the standard decimal equivalents of fifths are, but in case you don't, the way that you could work that out would be to divide, and you would divide the bottom into the top. So 5 goes into 3, doesn't, so you move the remainder along, and 5 into 30 goes 6. So 3/5 is equivalent to 0.6. As I said, chances are you knew that anyway. And because we're working to two decimal places here, we would write that with an extra 0 as well. So that is 0.60. So I've got a 0.65, a 0.60, and 70 over 100 again would be one that I would expect you to be able to write that straight down as 0.70. So we are now in a position where we can compare the size of those. That's the same as 65 pence written in pounds. That's the same as 60 pence written in pounds. And that's the same as 70 pence written in pounds. So to put them in descending order, you'd start with the 0.70. Followed by the 65 pence, followed by the 60 pence. But to be sure of the marks, you should put the figures in the same form that they've given them to you. So rather than write them all in decimals, we would now put them back. So that one was the 70 over 100. That one was 0.65, and the 0.60 was 3/5. So there you go, that's what they're looking for those marks. Question 2. A band hired a concert hall for 2 nights. They would only hire the hall for a third night if at least 0.9 of the tickets were sold for either of the first 2 nights. On the first night, 82% of the tickets were sold. On the second night, 3/4 were sold. Did the band hire the concert hall for a third night? You must show all your working, explaining clearly how you decided. Well, this is pretty much exactly the same type of question as the first one, but just in more of a numeracy form. We need to compare these two with 0.9. So to do that, I need to put them into the same form. So 82% is the same as 82 pence written in pounds. So as a decimal, is 0.82. So if we're comparing that to 0.9, it's less. That's 90 pence, that's 82 pence. So that's less than 0.9. 3/4, well, again, I would expect you to know quarters as decimals, but in case you don't, we would be dividing 4 into 3. It doesn't go. 4 into 30 goes 7 times. 7 4s are 28, remainder 2. 4 into 20 goes 5 times. So if you can't remember it, you can always work it out. That's 75 pence, which is less than 90 pence. So they would only hire the hall for a third night if at least 0.9 of the tickets were sold for either of the first 2 nights. Well, they weren't. That was less than 0.9. That was less than 0.9. So they didn't hire the hall for the third night. And we've decided, because we've said there 0.82 is less than that, 0.75 is less than that. Okay, question 3. Some non-calculator decimal arithmetic. Right, the way you would have been taught this would be to multiply the numerical digits together, so 4 7s are 28, and then count how many numbers you have after decimal points. 1, 2. That means there have to be 2 numbers after the decimal point in the answer. So that's going to be 0.28. This one is a decimal subtraction, which I'll lay out in column form. So the 7 is a unit, so that would go beneath the 3, and then I'd have that. So that's how it's laid out. I need a digit above that. If there isn't one there, I can put a 0 in. When you subtract, you work from the right to the left. 5 from 0 you can't do, so rather than write it as 80, you write it as 7010. 5 from 10 is 5, 4 from 7 is 3. Same here, you can't take 7 from 3, so you borrow from the next one along. 7 from 13 is 6. And you can always check that's right by, if you now add these two together, it will give you 13.80. 3 to the power of 3 means 3 times 3 times 3. 3 3s are 9, 9 3s are 27. 2 to the power of 4 means 2 times 2 times 2 times 2 times itself 4 times. 2 2s are 4, 4 2s are 8, 2 8s 16. We want to subtract those. 6 from 7 is 1, 1 from 2 is 1, so that's 11. 9/10 take away 3/5. We can't add or subtract fractions until the denominators, the number on the bottom of the fractions, are the same. So I can scale that 3/5 up to tenths by multiplying everything by 2. So 3 times 2 is 6, 5 times 2 is 10. That will then enable me to subtract. You don't subtract the number on the bottom, that's just telling you what the fraction is out of. So 9/10 take away 6/10 is 9 take away 3, 9 take away 6, 3/10. This one looks a little bit weird, 1 over 0.25. That's a reciprocal, but you can think of that as the same as what's 1 divided by 0.25. And hopefully you know that 0.25 you can also write as a quarter. So what this is basically saying is, how many quarters are there in 1? 1 divided by a quarter, you're sharing 1 into quarters. Hopefully you recognize that there are 4 quarters in 1. Question 4. A fair 6-sided dice is rolled. What is the probability that a 3 is not shown on the dice? Circle your answer. So what I would do here, before even looking at the answer, is work it out myself. I know that if I've got a 6-sided dice, probabilities are going to be out of 6. And how many ways are there of not throwing a 3? Well, if the answer was what's the probability that a 3 is shown, it would be 1 out of 6. So there are 5 ways that a 3 is not shown. So what I'm looking for is an equivalent of that, and I can see there straight away what we've got. 120 raffle tickets were sold at a fete. Sean has a 30% chance of winning the top prize. How many tickets did Sean buy? Well, to have a 30% chance of winning, she will have to have 30% of those raffle tickets. It's a non-calculator paper, so to find 30%, first of all we would find 10% by dividing by 10. So that would be 12 tickets, so 30% will be 3 lots of 12, which is 36 tickets. Part C. A bag contains a mixture of blue beads, yellow beads and pink beads. 1 bead is taken at random from the bag. The probability that the bead is yellow is 2/5. Which of the following sets of beads could have been in the bag? Circle your answer. Well, again, what I would do here is work out the fractions first of all. So in this bag, the chances of selecting a yellow would be 6 out of the total number of balls in the bag, which would be 15. In this one, it would be 5 out of 15. In this one, 1 out of 7. In this one, 5 out of 11. And in this one, 3 out of 15. So none of those are the fraction 2/5. So then we have to look at the equivalence by cancelling down. 6 and 15, 3 divided in 2. 6 divided by 3 is 2. 15 divided by 3 is 5. So straight away, that's my answer. Just to get us comfortable with cancelling down, with this one, 5 goes into both. 5 goes into 5 once. 5 goes into 15 3 times, so that's a third. That one, you can't cancel down any further. That one, you can't cancel down any further. This one you can. 3 goes into itself once, and 3 goes into 15 5 times. So those are the fractions in their simplest form, and we can see 2/5 is the first one. So that's what we want to circle. Question 5. The shop has 31 plant pots. Some are blue, some are yellow, and the rest are red. There are 5 more blue pots than yellow pots. And there are 4 times as many blue pots as red pots. Calculate how many pots there are of each colour. So this is something we're just going to try some numbers to see if we can get them to add up to 31. So if we think about red pots. Let's say we have 5 red pots. If we have 5 red pots, there are 4 times as many blue pots as red. So that's going to be red times 5. Sorry, red times 4. 4 times as many, which will be 5 4s are 20. Then the yellow pots, there are 5 more blue than yellow. So to get yellow, I've got to take 5 off there. So if I have 5 red, I have 4 times as many blue, which is 20, and I have 5 fewer yellow than blue, which is 15. The total has to come to 31. Well, here I've got 25, 35, 40. So that's too big. So let's try 3 red. So if I have 3 red, I have 4 times as many blue, 4 3s are 12, and I have 5 fewer yellow, which is going to be 7. If I add those up, I get 7, 10, 22. I want 31. So it's between 40 and 22, so I'm going to go for 4 red. If I have 4 red, 4 times as many blue, 16, 5 fewer yellow, 11. If I add those up, I get 20, 31. Job done. So how many blue? 16. How many yellow? 11. How many red? 4. Question 6. Team A and B play in a competition. Team B has 8 more points than Team A. Team B has 3 times as many points as Team A. How many points does each team have? So again, similar to the previous question, what we're going to do is try some values. So if Team A has 1, if Team B has 8 more points than Team A, that would be A plus 8, which would be 9. But Team B have also got 3 times as many, which would be A times 3, which is 1 times 3, which is 3. Now Team B, those values need to be the same. They're not, so A hasn't got 1. If A is 2, A plus 8 is 10, A times 3 is 6, still not the same. 3 plus 8 is 11, 3 times 3 is 9, they're not the same. 4 plus 8 is 12, and 4 times 3 is 12. They're the same, so that means that Team A must have 4 points and Team B must have 12. Question 7. A fraction is written as A over B. The fraction is a multiple of 0.1. It is smaller than a half, and it is more than 35%. Write down the fractions A over B, where A and B are whole numbers. So if the fraction is a multiple of 0.1, that means it could be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and so on. However, it's smaller than a half, so it's less than 0.5. More than 35%, and 35% is the same as writing 35 pence in pounds, which is 0.35. Well, 0.35 is going to be between 0.3 and 0.4. So it's a multiple of 0.1, it's smaller than a half, it's more than 35%, so the only one that's left is 0.4. 0.4 is the same as 4/10. So you could either write A and B as 4/10, or that does cancel down because you can divide both of those numbers by 2 to be 2/5. It's not asking it to be in its simplest form, so either of those would be correct. Use the fact that 5.3 multiplied by 8.6 equals 45.58 to write down, zoom in, it's a bit small, to write down the answers to the following. So, because those digits are the same as those digits, the answer is going to contain those digits. So the only thing that's going to be different is where that decimal point is. And that decimal point is going to be, well, that's 10 times larger than that. That's 10 times larger than that. So we're going to have an answer which is 100 times larger than that. 10 times larger than that would be 455.8. 100 times larger would be 4558 point. So 4558. Second one, 530, well, that gives me from there times times 43. Well, 43 isn't in the original sum, but 43 is half of 86. So what we are working with here is the digits are going to be half of those digits with the decimal points in a different place. So if I started off with 530 times 86, that would be 4558. It's going to be 100 times bigger than that and 10 times bigger than that. So it's going to be 1,000 times bigger than that, which would be 455 would be 10 times bigger, 8 would be 100 times bigger, 0 would be 1,000 times 0. So 530 times 86 is that. I want it times 43, so it's going to be half as much as that. So 530 times 43 will be 2 into 4 twice, 2 into 5 twice, remainder 1, 2 into 15, 7 2s are 14, remainder 1, 2 into 18, 9, 2 into 0, 0. So 2, 2, 7, 9, 0. And then for the final one, this time it's a divide. Now, what this means is that if we've got 4558 divided by 8.6, that would give me 5.3. So to take the original sum that they've given us and write it 45.58 divided by 8.6, that would equal 5.3. I've got 455.8, so 455.8 5.8 divided by 8.6. That's 10 times bigger, so the answer is going to be 10 times bigger. And then that becomes 10 times smaller to get the 0.86. And if you're dividing by a number that's 10 times smaller, your answer becomes 10 times bigger. So the final answer there is 530. Question 9. Clearly showing how you obtained your answer, estimate the value of 154 times 4023 divided by 590. Okay, so what you would do here is you would round to one significant figure. So the most significant figure is the 100. So you're either going to round to 100 or 200, and it's closest to 200. So that one becomes 200. This one, it's either going to be 4,000 or 5,000, and it's closest to 4,000. And then this one is either 500 or 600, and it's closest to 600. So on top we have 4 2's 8, followed by 5 zeros over 600. For each of the zeros on the top and bottom, you can divide by 10. So we end up with 8,000 over 6, which is the same as 4,000 over 3. So if we're going to do that, 3 into 4 goes once, remainder 1. 3 into 10 goes 3, remainder 1. And so on. So our estimate is about 1,300. Standard form. Okay, so in standard form, if I just rewrite this a little bit larger, we've got how many zeros? 1, 2, 3, 4, 5 zeros. So that's my number. The decimal point is there. This first digit is 10 to the power of 0. This one, 10 to the power of 1. 10 to the power of 2, 3, 4, 5, 6. So to write that in standard form, it has to be a decimal number between 1 and 10 multiplied by a power of 10. So I could write this as 1,200,000 times 10 to the power of 0, or I could write it as 120,000 times 10 to the power of 1, 120,000 times 10 to the power of 2, 120,000 times 10 to the power of 3, 120 times 10 to the power of 4, 12 times 10 to the power of 5, or 1.2 times 10 to the power of 6. It has to be a number between 1 and 10. So 12 times 10 to the power of 5 is too big. So it would be 1.2 times 10 to the power of 6. You may have been taught that to work it out, you count how many times you move the decimal point. 1, 2, 3, 4, 5, 6 to get it between 1 and 10. But in fact, it's not the decimal point that moves. What you're doing is reading off the place value. And the same with a small number. So if we've got 0.00123 that's 10 to the power of 0. When we go this side of the decimal point, they're to the power of -1, -2, -3, -4, -5, -6. So I could write it as 51 times 10 to the -6, but that's not between 1 and 10, so it's 5.1 times 10 to the -5. Or if you've been taught to jump decimal places, -1, -2, -3, -4, -5. Calculate the value of 4.8 times 10 to the power of 5 divided by 2 times 10 to the power of -3. So with this question, you work out the number part and the power part separately. 4.8 divided by 2 is 2.4. Now when you divide, and you need to have practiced standard form to do this, so I'm assuming that you have revised standard form, when you divide powers of 10, you subtract their powers. And when you subtract a -3, minus minus makes a plus, you will have been taught. So that becomes 5 plus 3, which is 2.4 times 10 to the 8. So you separate out the number part and work with that, and then deal with the indices, the powers of 10. When you add or subtract standard form, then the best thing to do is to turn them into whole numbers, write the whole complete number out, and then put it back into standard form. So if I go back to my powers of 10, both of these are positive. So there's my decimal point, 0, 1, 2, 3, 4, 5, 6, and so on and so on. So 3.6 times 10 to the 4, there's my 10 to the 4. And then I'd fill in with zeros up to the decimal point. 9.8 times 10 to the 5 will go there. And I'm adding them together. So 0, 0, 0, 6, 8 and 3 is 11, 9 and 1 is 10. So that's the number as a complete number, but they want the answer in standard form, so it's going to be 1.016 times 10 to the 6. Because the 1 is in the 10 to the 6. So that's standard form. Question 11, so this is now and the other bonus topic really. So we had standard form, which is a grade B topic, and product of primes is also a grade B topic that often students are quite confident with. So 240, what we do is repeatedly divide that by prime factors until we can divide it no further. So it's even, so we can divide by 2. 2 into that goes 120 times. I can divide that by 2 and get 60. I can divide that by 2 and get 30. I can divide that by 2 and get 15. 15 isn't even, so I can't divide by 2 again, but it's not a prime number either. But I can divide by 3 to get 5, and that's prime and that's prime, so that finishes off the division. So 240 is the same as 2 times 2 times 2 times 2 times 3 times 5. They want it in index form. That means they want you to write that rather than 2 times 2 times 2 times 2 as 2 to the power of 4. You're multiplying 2 by itself 4 times. Times 3 times 5. And if there's no power there, that means that you write it with a little 1 above it. Use your answer to part A to write down 240 squared as a product of prime numbers. So I know that 240 I can write as 2 to the power of 4 times 3 to the power of 1 times 5 to the power of 1, which I'm going to square. Again, I'll have to rely on the fact here that you know something about how powers work, indices, from some grade B revision. When you multiply a power by a power, when you raise a power by a power, you multiply their indices together. So that's going to be 2 to the power of 4 times 2 is 8. 3, 1 times 2 is 2. 5, 1 times 2 is 2. Part C, the number, that big number there, 387,420,489, is equal to 3 to the power of 18. Explain how this tells you that that is a square number. Square numbers, which you get from squaring something, always have positive powers. Even powers, sorry, not positive. So because 18 is an even number, that is a square number. So how this tells you it's a square number? Because the power, or the index, is an even So if that was a 17, that wouldn't be a square number. If it was a 22, it would be a square number. And that's it. So that's the first paper.